Okay, so we're going to real quick run through a couple of sample problems on this compound interest practice and the mixed review worksheet. So let's go ahead and look at problem number 1. Problem number 1 says that a computer valued at $1,500 loses 20% of its value each year, and it asks you to do 3 things. Write the function rule, find the value after 3 years, and determine how many years, or what is the x value, where the computer will be worth less than 500. So let's start by identifying the important parts of this function. Move this up out of the way. And first off, we want to remind ourselves what kind of a function this is. In this case, on the left-hand side, we're going to write that it's decay. Okay, that's step number 1. We're reminding ourselves that it's a decay function. Next up, we want to identify our 3 primary variables for that kind of a problem. So what we're looking for are a, b, and x. In this case, our a value is going to be our starting value, which is 1,500. Our b value is going to be that 20%, expressed as a decimal decay rate. So it's 1 minus 20 over 100, which is 0.8. And finally, we'll identify our x value. Our x value we talk about being each year, and when we get to part B, 3 years will be our value. But to start off with, we need to complete part A, which just asks us to write a function that models that value. So for part A, our function is simply building our equation with a variable for our time spot. So for A, it's going to be 1,500 times 0.8 to the x power. For part B, we're taking that same formula, but now we're inserting in our value of 3 years for x. So as we work through it, here's what it'll look like. We start out with 1,500. We're going to go ahead and multiply that by 0.8, and we're going to raise that to the 3rd power. As we work through this, we'll find that our value is, it is $768. Remember, you always want to put the unit signs on there. For part C, we're going to work on something a little different. It's asking us how many years will it take for the value of the computer to be less than $500. Now, it's possible just to say, well, x equals 4, plug that 4 into that, and see what happens. But that's not the fastest or easiest way to do it. So the simplest way to go ahead and do this is to use your calculator. If I take my calculator and I type in this equation, oh, I'm sorry, that's not right. If I type in this equation, the one with the x variable, into my graphing function, I can create a table by pressing second table. And that table looks something like this. This is a table that I created and pulled from the Desmos graphing calculator online. All we have to do now is look at it and figure out at what value of time, or x, does our resulting value, or y, is it less than $500? As we look down the list, the first time that it hits less than $500 is right here at x equals 5 years. So for part C, we'll just simply say that x equals 5 years. So when we're looking at one of these problems, you're just working it out just like we have before. Identifying your variables, identifying what kind of problem it is, writing your full equation, working it out with your units here. And make sure you include all of these pieces when you're solving these kind of a problem. Next, let's look at the second problem, example. So example number 2 is a very simple problem. It's just asking you to use the compound interest formula to find the value of this deposit. So so once again, let's start by talking about what kind of a problem it is. So immediately, because we see the word compounded, we're going to know that it's a compound problem. And so this should be written to the left side, just like we did on our previous work. Next up, we have to decide what are the important pieces. So in this case, I know that 13,500 is going to be important, and that's once again going to represent one of my variables. So let's list our variables. So our A value is what we don't know. That's our unknown. But our P value is this deposit amount of 13,500. As we keep moving through, we can see that our rate is 3.3%. So we get 3.3 divided by 100 gives us a decimal version of 0.033 for our R value. When we look at N, we're looking at how many times it's compounding. So the key word is monthly, which you should remember from your notes means 12. And finally, we have to look at our T value, which in this case is just 1 year. So now we have to put it all together into a single equation. And when we do that, we come up with this. A equals 13,500 times 1 plus 0.033 divided by 12, all of that raised to the 1 times 12. Now it's just a matter of using our calculator to plug it in and work it out. After you work this through in your calculator, you'll discover that our value for A is equal to $13,952.30. Remember, since we're talking about money, it's going to round to just the penny, or in this case 30 cents. So our final answer here should be that A equals $13,952.30 with, again, our unit sign out front. So for these kind of problems, anything that's a compound interest problem, you want to, again, make sure that you have all the correct values and information on your screen. What type of problem is it? What are all your variables representing? What does your equation look like? And what's your final answer? All of these things need to be part of your answer on the worksheet. So, as you're going through this worksheet, here are the things you need to remember. Every problem should show, is it growth, decay, or compounding? Literally, that means on the left-hand side, you should write out growth, decay, or compound to remind yourself what type of problem you're working with. Next, you want to make sure that you write down the values for each variable in the formula. If it's growth or decay, you're going to be writing down values for A, B, and X. On the other hand, if it's a compound interest formula, you'll be writing down A, P, R, N, and T. After that, you'll once again put a vertical slash through your problem so that all of this information here is on the left-hand side and everything else will be on the right. So what is the function? This would be A times B to the X power, or A equals P times 1 plus R over N to the NT. And then the final solution, so for example, A equals 15, whatever it happens to be, and all of this information should be on the right side of that vertical line, just like we did on the previous problem. If you have any questions, come up and see me, but other than that, go ahead and start working on the worksheet. This is an assignment that will be due this week on Thursday. So you have 4 days, Thursday, okay? All right, go ahead, get started.